Hi. In this episode, I talked to my esteemed colleague, Dr. Ian Oliver, about security and its relationship to the Raspberry Pi Pico and Pico W projects. Ian is based in Finland, hence the snow you'll see behind him. We've known each other since we were both PhD students back in the late 1990s. In this video, we use quite a few security terms. I've tried to put definitions for these up on the screen as we go through. Let me know in the comments if I've missed any and you need any explanations. Ian and I will be happy to add them. Please don't forget to like the video and to subscribe. I really do appreciate it. So I'd like to welcome Ian Oliver to the channel. Ian, we've known each other for nearly 30 years now, which seems an incredibly long amount of time. But for my wonderful audience, can you give us a bit of an introduction to you and where you fit into the exciting world of Picos?
Oh, good question. Where do I fit in? Okay, the 30-year thing's a bit terrifying for a start. I got along. Okay, currently I'm with Nokia Bell Labs. I work in cybersecurity, specifically um, hardware trust, confidential computing. Um, Basically, trying to make the world a little bit more secure from that level. I get into digital forensics, supply chain security, and all this stuff. So I run a small research group within Nokia Bell Labs and across the business units. But my history, yeah, going back 30 years. Yeah, I think actually we both started off looking at UML. And when people talk about UML, we can say, yeah, we predate everything you knew publicly by about 5 years. Um, you know, yeah, and in between there's been a lot of formal methods, hardware, software, co-design, and privacy, and semantic web, and all sorts of cool stuff. But for 10 years, I've been doing trusted and confidential computing.
Cool. No, thank you. And that's it. I do remember the world of UML, but I also remember about that time, still writing C++ code and some Eiffel as well. And what's changed? I still write C and C++ code now. The world
I,
hasn't really evolved
I,
that much, and I still play with
I,
Unix operating systems too.
yeah, I mean, I've got some students at the moment that I'm teaching to build basically embedded systems from Raspberry Pis, Arduinos. Um, I mean, okay, it's a little bit different where we're running things like message brokers like Mosquito and MQ, using MQTT on the Pis and bring all the stuff together like this. What's interesting is even though they're using languages like Python, they still have to dip down to C. Um, they still have to understand weird little things like, yes, global variables still have to be used. Object orientation isn't always going to help you, and so on. So they're learning to build these kind of weird embedded distributed systems out of larger blocks than, say, microcontrollers, but the patterns are all the same. So yeah, things haven't changed that much, I don't think. Eiffel, I remember that was my most favorite programming language ever. It was beautiful. I'm now very much a Go fan rather than anything else because Go actually feels like I'm programming in Ada again, and I liked Ada as well.
Well, Go, I believe, is available for the Pico, though I must admit I haven't tried it myself. So security and privacy, that's obviously, your big area of experience and expertise. Um, but, in the world of Raspberry Pi Picos and Pico Ws and those of us coming from a hobby world into that development, why should we care? Is really security something we need to worry about in what we're playing around with on these devices?
Okay, well, without going into the whole risk management argument, okay, at one level, nah, you shouldn't care at all. I mean, if you're building a little thing at home, get the functionality. However, as soon as you start connecting it to things, and you know the old joke, what does S in IoT stand for? Security. Um, I mean, I'll give you an example. Look, there's my home. There's a device that I've just pulled off my home network. So scattered around the house, I've got a whole little bunch of Bluetooth sensors that report pressure, temperature, and all this stuff. This guy picks it up. It's also got its own little sensor there. And then it broadcasts it to a little server I have running in Flux. There's no authentication running on this. There's no authorization. But that's a risk I'm willing to take at home. However, I have, partly for personal reasons, to figure out how security works within this and how we should worry about it. I've actually built my system to go and test certain things. So, for example, if you look at this little guy here, sitting here on the SPI bus is a trusted platform module. So, okay, the Pi really isn't a trustable device, but there's a trusted platform module there that I can do nice experiments with. And my little server in the corner has a trusted platform module. And I'm running things like IMA to do all the integrity measurement of the operating system. So if things change or I do updates, I've got to go and modify these things. I've got a remote attestation system that we built, talking to all my devices to make sure what state they're in. If not, then certain things don't happen. Maybe my little home Kubernetes cluster doesn't put certain processes on certain devices. By doing this, you get an appreciation of what security can give you versus just doing security for its own sake. So two things come to mind. One is many years ago, we were doing security for security's sake, and we were coming back. I was coming back for a conference. I was sitting on the plane. It had gone badly, the conference, not the plane. I have faith in Airbus. And I was actually thinking, yeah, nobody understands what the hell we're doing. So I sat down and wrote a little text file. John, you want to bleep out this bit because the text file is called "What the fuck am I doing?".txt. And in that, I actually wrote down, why don't people understand security? And it's because it doesn't help them. It doesn't give them extra functionality. It just gets in your way. And that's why people don't bother with it. So if you turn things around and actually ask, okay, if I add this piece of security into this, if I add a TPM into my device, what use cases does it enable me to do? How does it make my life better? What additional functionality can I offer to the end user? And there you've actually got to start thinking about who the domain users are. So we specialize quite a lot in railway and medical systems. And interesting question, if you have a TPM in a device, how does it make it better for, say, a doctor or a patient? And that's a very interesting question to answer. So I think if you want justification why you want security, think about it in terms of what additional functionality can you give to your end user? How does it make their lives better? If it gets in their way, the other case I want to bring up, and I do this in a lot of presentations I give, the first slide, I'm going to spoil this now for anybody who sees my presentations. Now you know the answer. This is how the world ends, by hacking one of these. And not just, if you're on a microcontroller, it means the firmware. If you're on a Pi, it could be anything from the firmware up to the operating system applications. This is how the world ends. And it's not by somebody doing a massive attack against a data center and setting it on fire and God knows what else. It's about people going in, changing the firmware on your devices in such a way that the effects of that change, A, are not being monitored for or detected, but B, it causes very, very subtle things to happen. And the classic example of this is Stuxnet. There's a bunch of PLCs. They're microcontrollers connected to valves and temperature sensors and motor controllers. And what happened in Stuxnet was the firmware was modified in such a way that it added jitter to the motors, destroying the processes. So the process for refining uranium, in this case, didn't work anymore. But it looked like a mechanical fault. That's, if you think, okay, attacking a uranium reprocessing plant is interesting, just think what would happen if every temperature sensor in your house started one day reporting 1 or 2 degrees higher or lower. It's very, very subtle, but think what that does to your electricity bill. How are you going to detect that? What happens then one day that, all the locks in your house, because everyone has internet connected locks, what happens if they all turn off one afternoon? What are the effects from there? So when you get into very, very small systems like microcontrollers, etc., I actually think it becomes much, much more important that you actually understand how these things are controlled, who is controlling them, what's on them, and so on. So the whole authorization, authentication, and integrity is very, very important. And when you get into areas like trusted computing, it's identity and integrity of the system. How do you measure these things? What is the identity? How do you discover if a new device appears on your network? So I've got a script that looks at my router. It scans to see what device is on there. Whether my router's DHCP tables and the way it reports them are any good is another question. Some days it doesn't even see my desktop machine, which is wired, and yet it still gives me an address. It doesn't tell me it's there, but it still gives me an address. If you monitor this, what devices come onto your network? And if you've got very dynamic networks like your home network, where devices come and go quite rapidly, if a new device appears on that network, don't you want to know who it is, and then what it's running, and is it authorized to be there, and so on. And for very small devices, little temperature sensor with a Zigbee network on it, yeah, I can add one of those to your house, and you might never notice. Any device that has smart in its name is a potential vector for this, and we just don't go and look at this.
And then, one of the stats that I think frightens me in this world is, is the number of the devices that are now making up the farms of denial of service attacks. Actually, they're no longer large computers. In actual fact, they're CCTV cameras, sensors that people have got in their house, smart devices that they've bought. And those have all been hacked, and they have become this IoT army. So this denial of service army that criminals are using to disrupt the internet. And that is extraordinary that actually those devices are things we would not think of as being dangerous, but in actual fact are.
Yeah. I mean, look at your average smart TV. It's a small ARM or x86 computer. Yeah.
Okay, let me wind you back a bit, because I'd like to go in a little bit more about talking about how people really start to think about some of these security and privacy skills, and what that sort of awareness looks like. Because I think you've touched on the 3 A's of security, which is what I always talked about when I was working in the world of architecture. Authentication, authorization, and audit. But you've also added into that one addition that I didn't often think about, which is integrity. So could we just go through these and just give a short explanation of what do we mean? So when we say authentication, what do we mean?
That tends to be a very catch-all word for a lot of things. It can come down to are you who you say you are, which is an identity characteristic. It's something that comes out of a set of identity characteristics. So if you can't, you might be authorized. We get the words wrong. You might be authorized, but you might not be authenticated. Meaning that I might have proven that I can have these rights, but I'm not the person who wants them. So the two must be taken together. I think authentication also plays very much into the integrity part. And I think this is the area where we're most weak. So integrity is basically asking the question, what are you? And I like to give an example. I'm just looking. I've got an old, it's an old badge. So this is my old work badge. There you are. This gives me the authority to walk in and out of buildings at Nokia. This one doesn't, because it's way out of date now. Does it prove who I am? And this is where it gets interesting. We've done experiments walking on various buildings, i.e. not wearing a badge for weeks on end, or swapping badges around. I mean, we went to our last conference, security guards on the door, we walked straight through, and my student at the time, she says to me that they didn't check our badges. I said, oh yeah, they did. They were looking, were they the right shape? Did they have a face? And did they have the Nokia logo? I said, as it was, I don't look like a tall blonde lady, and you don't look like a devastatingly handsome Welshman. So, but we still got in. Um, so integrity actually is asking, does this set of credentials that authorizes me and authenticates me, does it match exactly who I am? And we don't make that check often. So integrity, what are you? So this device, it's a Raspberry Pi. Ask the question, what is it? What is it running? Is it really running the code that listens to my Bluetooth sensors, listens to this sensor and broadcasts it over MQTT to my little server? I can do the authorization and authentication to do that. That's quite easy. I might have some keys set up to make sure you can talk to my little influx server. The influx server account on there says, well, okay, that key is authorized to write data and read data, and so on. But neither side actually have proof that this really is valid software writing that, and that's the thing that we are missing. Just because you've even written the code yourself doesn't mean that the binary running on these things, when you go and upload it to your Pico, when you update the firmware, there's still no guarantee that what you put on there is really what's actually going there. And interesting, don't even think that signing the binary is going to get you out of this either. Just because it's signed doesn't mean that what's contained inside is really what it is, what you think it is. SolarWinds is a very good example of that. So where somebody actually managed to tamper with the compiler, which outputted the executable, which was then signed and then loaded up.
Indeed, yeah, you can fool these things. Though most people on the Pico, it is unlikely, unless someone can physically get access to the device, that they're going to be able to put any malicious code on it, which is nice. Very few people do over the air updates on a Pico. And as I've explained to a few people, if you can physically get to my Picos, then I think I've got a bigger problem because you're already in my house.
Yeah. Yeah, I mean, we used to have that. Somebody saying, so what happens if somebody gets to the TPMs in my server farm? Well, if somebody is able to pull the servers out of their racks and tamper with them at that point, yeah, you've got bigger problems. There was this, I think it was a Black Hat 2014, there was a brilliant presentation about the guy who extracted the keys from a TPM, chemically etching away the plastic and using an electron microscope, and that took him 6 months. And somebody actually asked me, what happens if somebody does that in our data center? And I'm thinking, where are you getting why have you got an electron microscope in your data center? And how is it mobile? So, but when you're down to physical access, I mean, at that point, almost all bets are off. But from my point of view, so for example, Nokia builds base stations, and those base stations and other equipment go out into relatively unprotected areas. If you want physical access to a base station, you see them on tops of buildings, not just on tops of towers. We got the micro and pico base stations that you can sit on your ceiling. It's a 5G base station. You've got physical access to these, and these things are connecting to, at least in US terms, what's called critical infrastructure. I think in the EU, it's now, hopefully it's classified as critical infrastructure, and you've got physical access. Now, maybe these things aren't the easiest to program, but the knowledge is out there. And I don't think, it's too difficult to find people with the right knowledge to go and attack these things at source. So, and even in the smaller designs, I mean, you've got they're system on chip based systems, ARM based, x86 based. None of these are particularly exotic. So I think as soon as you put a device in an environment where that environment is insecure in some sense, then you are taking a very, very big risk. And at that point, you will want some mechanism by which you can ensure that no unauthorized software is put onto the device. And if it is, because we want to catch as many holes as we can, you want some mechanism for being able to attest that device and for it to prove its trustworthiness.
We've touched on, or you've touched on TPMs several times in your. Tell us a little bit about what a TPM is. Is it really related to a could we use one with a Pico W, and would that help or solve the problem?
Okay, so the TPM itself is a small, secure cryptographic chip. It's got no processing capabilities. It's very much a passive device, but it's got key generation functions, crypto functions. It's not fast. It's not a crypto accelerator. It's got some memory, but don't expect to store thousands of keys on this like you would an HSM. So it's not designed for that. It's got similarities. It's got NVRAM. It's got some seeds from which you get key derivation functions, so you can prove the identity of the device. It's got a set of registers called PCRs where you can store measurements, cryptographic hashes, by extending them and so on. And then it's got a very, very interesting policy and session mechanisms, which allow you to seal certain areas, keys, functionality, NVRAM, etc., against particular combinations of measurements stored in the PCRs, passwords, and other authentication properties. So you now have a secure place in which to store secrets. So so if somebody goes in, for example, on your laptop, changes a configuration setting in UEFI, you're going to get different measurements in the TPM on your laptop, and that actually might prevent the TPM performing certain functionalities, encryption, decryption using certain keys, or releasing NVRAM. So it becomes a very secure way of doing that. But, and this is very, very important, the TPM, if you've just got a TPM in there, you don't get any of this because you need the infrastructure around it. And you need at least a core root of trust, so the point immediately on power on that starts recording measurements of your system, i.e. what it's going to execute. So that needs to be typically in ROM. And then your firmware should ideally be creating logs. UEFI does, but I would hate to see UEFI on a Pico or any small device. It's bad enough on x86. But your firmware should go along and actually collect information. So you've got the cross-referencing there. That then takes you very much into also supply chain, which, where do these known good values, the measurements that you test against and verify against, where do these come from? So if you've got a supplier, so you've got a Pico, it's got some firmware on there already. Whoever supplies that should also tell you that when you boot up, you should see these values in the PCRs of your TPM. You should see this identity, these keys, etc. And you can start verifying in interesting ways. So it's much more about the infrastructure around the TPM. It's just the TPM is the enabling tool, if you like. It's not the only tool. We've got things like OpenTitan. AMD have firmware TPM or software TPM running on the CPU. Intel have PTT, which is a firmware TPM. It's about the functionality in the system. The TPM is just one, is the canonical example of this.
That's all cool. Really interesting. Thank you. And I'd add to that although a TPM is not really a crypto accelerator chip, actually, all the TPMs, even the very cheap ones, can actually do SSL style encryptions much faster than a Pico W can. So you are actually potentially getting crypto acceleration for SSL or TLS communication for the internet, and potentially key storage, both of which are a bit of a pain on a Pico W, to be honest, because writing to flash is not the easiest thing to do. If you actually can therefore update your keys in an external device that's designed to be able to store them, actually that's easier. So this can actually make your life as a developer easier rather than necessarily just adding a whole set of additional red tape to get through.
Yeah, I mean the nice thing about TPM is that you don't have to use all the functionality. If you want to use it as a very tiny HSM, that's fine. I mean, a very common case that we see is you have different sets of keys on the TPM for the TPM hierarchies, and that's another piece of its functionality. These are called authorization hierarchies. So as the manufacturer, you can put your own keys on. As the platform vendor, you can put your own keys on, etc. And as the user of the system, you can put your own keys and functionality on, and so on. You can then, once you've got that, then in software you can do TPM-backed key storage. So, for example, with SSL keys, also you might not be able to. If the TPM won't release the master key, then you can't decrypt your SSL keys, which probably just sit on the file system and so on. So it's one part of a larger set of security functionality, and it does make certain things easier, but it does come at the expense of having the infrastructure around that. And that's before we get into very cool things like remote attestation. But I'd like to say, I mean, I think you've touched on it. If you're going to do this, how does it make it better for the end user? What additional functionality do they get? And that, when we say functionality, it doesn't need to be some functionality they can use. It can be something that ends up being exposed to them as being sort of one of these non-functional functionalities. I'm trying to think back to my software engineering days. I can remember Franco Civello's lectures on this. Franco, if you're watching, thanks.
I'll say hello next time I walk into him. He only lives around the corner from
me. So if you're just doing this for home stuff, it's a nice thing to do. It gets you very much into the whole identity, integrity, crypto function stuff, and at the hardware level, and it gives you a new appreciation for how firmware should be written and how secure firmware is written and how you build secure devices. If you start moving this out into if you move these devices into production or into insecure domains, then you will want some mechanism for keeping track of these. Supply chain is a critical one. Which devices have you sold? What's out there? How do we make sure they remain secure? And as we're seeing more and more of these in more interesting domains, medical, for example, if you open up any home medical device, it's pretty much a microcontroller inside. I'm pretty sure you don't want people tampering with off-the-shelf microcontrollers that sit in your medical devices. We've been looking at a number of medical devices. These are based on ST32 system on chip. Yeah, we can change the firmware on them. We can get them playing Doom. It's not a problem. Maybe some of the user interface stuff is a bit of a problem, but the game engine we can run on these systems. Do you want somebody with that ability? And as these devices get more connected to the internet, they have more sort of control mechanisms, external control. Who do you want controlling them, and so on. But we get into that's another conversation.
I agree, and an interesting one. I'm thinking, my blood pressure monitor is internet connected. I use it to store all my blood pressure readings, which then go to my doctor, and my medication is dependent on it. So, if someone hacked that and started adjusting my the readings, my doctor would potentially start killing me.
Yeah, and here's the thing: how would he detect if it's a firmware attack? And these devices are insecure at that level. I mean, the whole point of your channel is to teach people how to use Pico. I mean, it's not hard to program for. It's not like microcontroller programming 20 years ago or 30 years ago. It's these are off-the-shelf tools for doing this. But yeah, how the world ends. Let's get everyone's blood pressure systems reporting it their blood pressure slightly lower. And if the system is providing that information, it goes across the internet. It's all authenticated, authorized after that point. How do you know?
Cool. Thanks, Ian. I know you have a book out on privacy engineering. Um, how could that help people coming to the Pico thinking about development? Is that a way to begin the education in this journey?
Right. I conveniently have a copy here. Okay, it's nearly about 10 years old now, which is frightening, and I'm still writing the sequel. Um, yeah. So when I was working with privacy, we had the lawyers on one side and we had the engineers on the other side. And the lawyers would say, here's a 200-page legal document. Are you compliant? And the engineers just, I'm not reading that. I don't think the lawyers did either, but that's besides the point. And so I had to somehow unify these two worlds. And it comes down to the fact that if you have any information system, and a Pico providing data is an integral part of any information system, is where is that information going? What is it providing, and where is that information going? So the whole point of the book was to talk about data flow and how you'd annotate the data flows in your system. So um, for an individual device, okay, you need to know what it's going to produce. And temperature measurements, humidity measurements, etc. Maybe it broadcasts its location and its identity. Okay, there's already an interesting privacy issue. It's a very small one, but in all of these cases, you need to know where this stuff is flowing, who is gathering this together. So if you take this device on its own, what can I infer from this temperature sensor? Well, I can probably figure out with a little bit of machine learning or just good old-fashioned detective work when I'm in the office, because the temperature goes up slightly. I can discover things that if the temperature really spikes, then I'm probably doing some aeronautical simulations on my machine, which is really overtaxing the graphics card. It's flight simulation, but don't tell anybody. So you can, these are very, very subtle things. When you start getting a lot of this over time, my influx server here, I've got a nice database of 7 days of data. I can pretty much figure out who's been at home, when they've been at home, etc. If I couple that with what devices I've seen on my network, there's another data flow. Now I know who's been in my house when, and I can probably even figure out which rooms they've been in. So understanding how your information is flowing around the system and what it can tell you, I think is just a good skill anyway. And if you're producing the devices that generate this data, it's a critical skill. You don't need to get into the legal side too much, but just the ability to be able to understand where things are going and what you have in your system is critical, which then also forms which leads into another skill which has been long forgotten for some reason in computing, in British news, which is this idea of systems thinking. Nothing sits alone. So as you've got to think of things as larger systems, lots of interacting items. So as an exercise to your listeners, let's say you've got a home network. You've got your routers with the DHCP tables, you've got smart light bulbs, temperature sensors, etc. What happens if one of these devices starts malfunctioning? What happens if somebody tampers with a single device on there? What's the absolute worst they could do? And I think, okay, even if that's even extreme, I mean, I'm not sure how much of a TCP/IP stack you can get on a smart light bulb, but probably quite a bit actually. If you've got that device potentially making other connections, abusing its radio network, if you've got that device as being a conduit to accessing other parts of the systems, then the potentials for a disaster gets very, very big. Now, instead of thinking about your own house, think of this as a hospital or a railway or a nuclear power station. And you start to see that unless security is actually baked in at the systems level from the bottom up, you get yourself into some very, very interesting places. Um, so I think these are skills that we need to ensure the engineers have. And even if you are working with a microcontroller and a tiny little Atmel chip or whatever, these are critical things to think of. And it might not affect you directly right now at the start, but it's going to come back and haunt you at some point. And your stuff is going to be used. So why not think about this right from the absolute beginning and sort of build with that in mind?
Cool. No, thank you very much, Ian. That was brilliant. And, thank you very much for joining me for this chat today. It's been great. Hopefully we can perhaps do some follow-ups in the future and perhaps do a few demos of privacy and security around Picos.
Yep, yeah, absolutely. Absolutely.
Cool.
It's great fun talking to you, John. Pleasure.
I always enjoy talking to Ian. He's knowledgeable and puts ideas across in an entertaining way. I hope you enjoyed watching as much as I did chatting to Ian. Thank you very much for watching. Please like the video as it helps others find it, and please subscribe and hit that notification button so you don't miss the next video. Goodbye for now.